Hello everyone, today we shall discuss about the rectifier. What do you mean by rectifier? Rectifier is an electrical device that is composed of one or more diode and that converts AC to pulsating DC. We can pulsating DC, or you can also say it will convert from AC to DC. Coming into the types of rectifier, there are two types of rectifier. One is half wave rectifier and full wave rectifier. What do you mean by half wave rectifier? You know, AC signals as both positive and negative cycle. So you should understand first of all what do you mean by half wave rectifier. So half wave rectifier is a circuit which converts positive half of the cycle of input signal to a DC level. Okay, it is a process of removing one half of the input signal to establish a DC level. That is called as half wave rectification. Half wave rectifier, it conducts current during positive half cycle of input AC signals only. The negative half cycle will be suppressed. By looking at this diagram, you will understand what do you mean by half wave rectification. You can see the diagram here. This is a AC supply. Usually the AC supply will be 230 volts to 50 hertz. So this is a step down transformer which steps down the voltage to a lower voltage. I mean your 230 volts will be stepped down to 10 volts depending upon the application again. So this is a step down transformer which steps down the voltage and then that will be given to a diode. So here you can see, as we all know, it is a diode that conducts only in the forward bias. Diode does not conduct in the reverse bias. So when the positive half of the cycle input is given to a diode, what happens? The diode will be forward biased and diode conducts in the conducts during that time. So output what you get will be the pulsating DC. Okay, so during the negative half cycle, what happens? This negative cycle will be given to the diode positive part. So what it happens here? Diode does not conduct during negative half cycle. You don't get any output here. You can see here, this is the output graph, output current and output voltage. So overall what you need to understand is, you have given an input AC, the output what you get from the RL load resistance will be the DC. So what is the input we are giving? 230 volts, 50 hertz. It is given with the step down transformer. You can see it steps down the voltage to 10 volts. So AB, where you get 10 volts over here, that will usually be as input signal. So during the positive half cycle, diode does conduct. During positive half cycle, it do conduct. During the negative, it will be forward bias, hence it conducts, and output is taken across the load resistance. During negative half cycle, diode does not conduct and you don't get any output during the negative half cycle. So that is why we say it will suppress the negative half cycle. Okay, so this is all about the half wave rectifier. So this is the formal operation of it. AC voltage across secondary terminal AB changes its polarity after each half cycle. That is what I say. This is your sine wave. So initially this will be given and second time this will be given. So this is what it says in the first point. During the negative half cycle, the terminal A is negative, so that the diode is reverse bias and diode does not conduct. So during positive half cycle it will conduct, during negative half cycle it does not conduct. So the current flow through the diode during the positive half cycle only, In this way, current flow through the load resistance. So you can see the output, what with respect to input, what is the output you get. This is your input. Output, you do get the output in the positive half cycle. Negative half cycle you don't get. Again, in the positive half cycle you will get the output. Output frequency of half wave rectifier is equal to the input frequency. The frequency remains same. So F out is given by F input. Coming into a advantages and disadvantage of a half wave rectifier. Advantages are the circuit of half wave rectifier is very simple and low cost. The disadvantage of the half wave rectifier is the pulsating current in the output contains AC components whose frequency is equal to the supply frequency. So filtering is needed. So the thing you need to understand is some amount of AC component is still remaining in the output. So we need some filter circuit to get a pure DC. So AC supply delivers power during the half cycle only. So output is usually low. So this is all about the half wave rectifier. In the next video we will look into what is full wave rectifier and what is the advantage or disadvantage of the full wave rectifier as well as the operation of the full wave rectifier. By this I end this video. In the today's video we shall discuss about the full wave rectifier circuit. So by looking at the circuit, what can you notice? What is the difference between the half wave and full wave rectifier? The only difference is you have two diodes here, 1 and 2. That is a major difference. The supply whatever we give will be 230 volts, 50 hertz, the same supply. This is a step down transformer which steps down the voltage. I mean 230 volts to 10 volts. It can step down to any of the voltage. It is downing the voltage. So the input has been given to a diode D1 during the positive half cycle. Again you have two parts here. During positive half cycle what it happens and during the negative half cycle what it happens. During positive half cycle, so input what we are giving is a AC input. It has positive as well as negative. During the positive half cycle, diode D1 will conduct and D2 will act like a open switch. I repeat it. During the positive half cycle, diode acts like a closed switch. It will be forward biased and diode will conduct and you will get the output across the load resistance. I repeat it. During the positive half cycle, diode D1 will conduct, D2 will not conduct. Okay. Diode D1 will be forward biased, D2 will be reverse biased. It is not conducting. Okay. During the negative half cycle and output will flow across the load resistance. So you can see here in the output graph, during positive half cycle diode D1 will conduct, during the negative half cycle diode D2 will conduct. Same goes on repeating. So this is all about the working of the full wave rectifier. What are the advantages and disadvantages of the full wave rectifier? So there are few advantages of the full wave rectifier. Full wave rectifier have higher rectifying efficiency than the half wave rectifier. This means it can convert AC to DC more efficiently. They have low power loss because no voltage signal is wasted in the rectification process. The output voltage of the center tapped full wave rectifier has low ripples than the half wave rectifier. These are the few advantages of full wave rectifier. Coming into a disadvantage of the full wave rectifier, the center tap rectifier is more expensive than the half wave as well as it occupies lot of space. So these are the few advantages and disadvantages of the rectifier. Things to remember here is the circuit. First is the circuit, then how the diode directions are there. That is the next thing what you need to remember. Then how it actually works during the positive half cycle, how it works in the negative half cycle. After writing those two working, then you are supposed to write the advantages and disadvantage. Okay, by this we will end this video explanation about the full wave rectifier. In the next video we will discuss about the bridge rectifier. Okay, thank you. Type of full wave rectifier, that is called as full wave bridge rectifier. The main difference between the full wave rectifier and the full wave bridge rectifier is there are 4 diodes. There we had 2 diodes. So full wave rectifier has 4 diodes arranged in the form of bridge. The main advantage of this bridge circuit is that it does not require a special center tap transformer. The single secondary winding is connected to one side of the diode bridge network and the load is to the other side. You can see the diagram of the bridge rectifier. The main thing to remember here is diode direction plays an important role here. The same way the input, whatever the input you have given here, will be in the form of step down transformer, same AC input which you are giving to a rectifier. Here you have 4 diodes which is arranged in the bridge way. So during the positive half cycle, what it happens, so you can see the things to remember here is D1 and D4 will be in the same direction, D3 and D2 will be in the same direction. The output is taken across the load resistor. Okay, during the positive half cycle, diode D1 and D4 will conduct. During negative half cycle, during the positive half cycle, diode D1 and D4 will conduct. It will be forward biased, and during that time diode D2 and D3 will be reverse biased. It acts like an open switch. Okay, during the negative half cycle, diode D3 and D2 will conduct, will act like a closed switch. It will be forward bias. During that time D1 and D4 will be reverse bias. It is very simple. During the positive half cycle, diode D1 and D4 will conduct. Remember this. During the negative half cycle, D3 and D2 will conduct. Positive half cycle, diode D1 and D4 will conduct. During the negative half cycle, D3 and D2 will conduct. So by this you can see the output here. How do you get the output? Because as we have 2 output, during the positive half cycle both the diodes will work. During the negative half cycle other both diode will work. So you will get an output in this way. Okay, we can also say that output is equal to twice the frequency of frequency. So it is given as output frequency of full wave rectifier is equal to double of input frequency. So that is F out is equal to 2FN. So coming into a disadvantage and advantages of the full wave rectifier. Advantages are need a center tap transformer is being eliminated, and we have a twice output than the center tap circuit. The disadvantage is we are using 4 diode and internal resistance voltage drop is twice than that of center tap circuit. So you can see here the difference between the full wave, half wave and a bridge rectifier. So particulars is being mentioned in the left side, that is maximum frequency VDC, average current diode, ripple factor, peak inversion voltage, output frequency, center tap, transformer utilization factor, form factor, peak factor. You can just go through it. You can just make sure what is the major difference between these 3. Okay, by this I will end the video. Thank you.